Well, this is just another old Santa Fe courtyard stuffed with colourful knickknacks for the tourist trade, you might think. But actually, this was once the most secret address in the world. It was simply a post office box, 1663, and it was the only conduit to a rather special place in the mountains. So this is the center of nuclear America, the nucleus, if you like, the cradle. It's where it all began. It's where mankind first learned to harness the power of the atom. Both a terrible and a magnificent event, I suppose. And that building there, that half-timbered building, was in the 1930s and 40s a school. It actually boasts such alumni as the literary figures Gore Vidal and William Burroughs. And it was that school that was bought by the US government and formed the kernel of the Los Alamos Nuclear Research Laboratory.
This is the quark bar in Los Alamos. Those of you who are good at physics might remember that a quark is an elementary particle named after a James Joyce word. I don't know what this place makes me think of. There's something very moving and very extraordinary about the photographs of the pioneers of Los Alamos. It's kind of science, and there's an optimism in being American. And when the two come together, you create an astonishing energy, rather like the energy that they created when they split that atom and made that first bomb. I suppose some people would think this is a grisly place. It's a place of death. But to me, I see nothing but optimism. That's probably because I believe in science. Many people these days don't. I think America, for all its faults, still does.
Los Alamos still looks after America's nuclear arsenal, but with its $2.5 billion budget and its massive supercomputers, it's at the cutting edge in practically every area of research. Terry Wallace is Director of Science at the lab. Oh, that's the most beautiful thing I've ever seen. I can't begin to guess what it does. Terry, what?
So what we really have here is a very fancy electron microscope. So we're allowed to be able to look at materials, or prepare the materials and look at them on a submicroscopic level, and at the same time be able to probe it with ions so we can get the chemistry, the dynamics, the materials.
And it's everything from organic matter to wafers of this, that, and the other, is it?
The work that's going on in this particular one right now really is concentrated on films in which we can push individual atoms around on the film. And the idea would be able to build atom-based circuits so you could have a quantum computer. So this is actually
Los Alamos National Laboratory.
They're taking individual hydrogen atoms and moving them. And so those are hydrogen atoms.
You are actually corralling a hydrogen atom, pushing it into...
Yes, we grab those with probe tweezers and we can spell out lanol.
So you have all this power of quantum mathematics behind you and this extraordinary supercomputer. Are there other areas that you're developing?
A substantial effort in what we call living machines. So can we make materials which self-reproduce? Now, the idea there that we're working on right now, and the research is not focused on making living systems, but systems which are self-aware. And so the example I would use is, if we could, instead of having just normal concrete on a bridge, we could have this self-aware material on the outside, it could heal its own cracks with stress, you know, and time comes along. And so I think this is a very realizable dream. Our laboratory is here for one reason, and that's national security science. But to be able to get to the national security science, you have to be at the frontiers of science. And since so much good work is done here, it's attacked about 3.5 million times a day from all the different ways to try to, you know, either probe our information.
Hackers try and get in.
But they're mainly state-sponsored hackers. And so...
really?
And so
countries which we won't name, but let's say they rhyme with China and Bussia, actually have people constantly, as it were, hammering at your digital gates, trying to get in.
Exactly.
Oh my goodness.
And so,
I dare say Britain does too. When the theory and then the practice of the power of the atom was proved, it was the most momentous moment in science's history, really. Is there anything in science now which will yield equivalent astonishment, do you think, in the future?
The real answer, I mean, we don't understand dark energy. So our solar system is filled with dark matter, and we see the interaction with dark energy. And
because energy and matter are, in some sense, consubstantial because of Einstein.
Exactly.
Yeah.
And so potentially, the concept of what we could get from dark energy or the conversion with dark matter could dwarf anything that we see within our particular system of the light matter or what we see.
Leaving the boffins at Los Alamos to ponder the conundrum of dark matter and dark energy, I head for the